we are gonna, this lesson isn't too long, I don't think, but it's gonna depend on how many questions we have and stuff like that. So we're gonna go ahead and get started. Section 3.4. We're gonna cover 3.4 tonight. Next week, spring break. The week after that, we'll do 3.5 and 3.6. The week after that, we'll do 3.7 and 3.8, and then after the week after that will be our test. So we've got 5 sections on this one. So last one had 4, this one has 5. So, but that's why I cut this chapter in half, because otherwise it would have been really a long chapter. So, okay, we want to talk about or remind ourselves about division, because we in this chapter are going to be doing division with these polynomial expressions that we've been kind of working with the last few weeks. So before we do that division, we want to review how we do long division with just numbers. Okay, so some of you may not have done this for a really, really long time, because it's like probably 3rd, 4th, 5th grade somewhere, I'm guessing, when you do that. So I'm guessing it's been a couple of years for some of you. But when we do this, we make this nice little symbol right here, and we put this first number inside of our division symbol. Okay, so and it's usually the big number. Yes, 1,579 is going to go in there, and then we put the 32 on the outside. Okay, and then we have to ask ourselves, how many times does 32 go into 1? And it doesn't go into 1. And then how many times does 32 go into 15? It doesn't go into 15. And then how many times does 32 go into 157? And that's where we have to kind of estimate a little bit to figure out, you know, it probably goes in there about, how many times do you think?
4.
4 times? Okay. Yeah, that's a good guess. Usually people say 5, but okay, so 32 times 4. And we multiply the 32 times our guess of 4, and we put an 8, and we carry the, no, there's nothing to carry. So we have 128. Okay. Now, 128 is pretty far away from 157, so let's check 5 just to make sure. Okay, so we would take 32 times 5, and we would get a 0, carry the 1, and 160. So that one's too big, so you were correct with your guess of 4. So what do we do with this 128 now? We put it under here, and you're exactly right. We're going to subtract it. So we're going to subtract, and we'd have to do some borrowing. So 17 minus 8 is 9, and then 4 minus 2 is 2, and 1 minus 1 is 0. And so we get 29. And then we put our 4 right up here, because that was correct. You guys got the 4, and we put that above the 7. Then what do we do?
Bring down the 9.
We bring down the next number, the 9. And so it would be 299. And how many times do we think that 32 is going to go into 299?
9.
9 times. Let's check it out. 9 times. 32. We know it's not 10 times, so 9 is as big as it could get. 2 times 9 is 18. We carry the 1. 27 plus 1 is 28. So yes, that will work. And so we subtract again, right? And when we subtract this time, that's much easier. We get 11, and we put our 9 up here. And what we're going to do at this point, we're not going to add a decimal point and then keep going forever and ever, because with polynomials, adding a decimal point doesn't make any sense. And that's really what we're reviewing this for. So what we're going to do is there's 2 ways we could write our answer. The first way you probably learned back in elementary school was you just say remainder 11. You remember doing that?
I learned this yesterday.
Okay, you learned it yesterday. The other way of writing this answer would be to take that remainder and write it as a fraction, 11 over the number that we were dividing by, 32. So that's the 2 different ways that we will write these. We are not going to add a decimal point and keep going, because like I said, with polynomials, that won't make any sense. Okay, so does everybody kind of remember that from the past? Having done that at least maybe once or twice long, long ago in a land far away, or maybe down the street?
With my son.
What's that? You did it with your son?
Yeah.
Okay. In Purdy? Okay. So are we okay with that? So now what we're going to do is we're going to use this pattern to help us with doing the same thing with polynomials. So let's see. We got our answers there. We were correct, so that's good. It's always good when we get the right answer. All right. So now we're going to do something very similar, but with polynomials. So we're going to draw our division sign here. And we're putting this first thing inside because it's this divided by that. So x cubed plus 4x squared minus 5x and minus 14. And I think that's on your papers, right? So hopefully we don't have any trouble with that. And then on the outside, we're going to put x minus 2. Okay, and you're right, there's not enough space there probably to do that on your paper unless you write really, really small. So you may have to, I just wanted you to have the examples, but you may have to do the work on a separate sheet of paper. So here's where things are a little bit different. It's kind of hard to say, oh, how many times does x minus 2 go into something, right? So here's what we do. Our goal is to make this term cancel out. We're always going to try and cancel out one term at a time. And we're going to try and get rid of this one first. So what we have to do is we have to take this x, the first term over here, the x, and turn it into this so that when we subtract, it will cancel out. So here's how we figure out what to multiply by. You know how with numbers we just kind of guessed, oh, I think it's a 4, or I think it's a 5, or I think it's a 9, or whatever. Here's what we do to figure out what we have to multiply by. We take this term that we're trying to cancel out, and we divide by this term that we already have. Okay? So I'm actually going to do that over here. X cubed divided by x. So thinking about your rules of exponents, what are we going to get when we take x cubed and divide by x?
X squared.
X to the second, x squared. Okay? So here's what that means. We are going to take this, just like we did with the 4 and the 5 and the 9 last time. We're going to take the x squared and multiply by the x minus 2, just like we did with the 32, right? Last time with the 4 and the 32 and the 5 and the 32 and the 9 and the 32. So when we multiply this, what do we get?
X cubed.
X to the third, x cubed.
Minus 2x squared.
Minus 2x squared. And so what we're going to do then, just like we did last time, is we're going to take this and put it under here. Okay. Does that make sense so far? Yep, no problem.
Wait, so when you divide it, you just do 3 minus 1?
Yeah, you just subtract the exponents. Because the idea is, you're talking about this over here, right?
Yeah.
Because the idea is you've got 3 x's multiplied together. That's what this means, divided by 1 x. And so one of them just cancels out.
So, for example, the top one was x to the power 4 and the bottom was x squared.
It'd be x squared again.
It'd be x squared again.
Or if the top was x to the fourth and the bottom was x cubed, it would just be x.
So, yeah, okay.
Yeah, you just subtract the exponents. Is everybody caught up? Okay. So now, remember what we did with the numbers. When we wrote it under here, what did we do? We subtracted, right? So here's what we have to be careful of. There's multiple terms here. It's not just one number that we're subtracting. It's multiple terms. So here's what we're going to do. And here's a little rhyme to help us try and remember this, that we do want to subtract.
What do we
Okay.
put on the top?
I'll show you that in just a second. So actually, we can do that now. We're going to put this x squared, remember, because that's what we're multiplying by. We're going to put that x squared right up here. And it doesn't really matter where it goes, but I usually like to line up my x squareds. So I put them all in a row or a column or whatever. Okay, so here's what we're going to do. We want to subtract. So here's how we subtract when we have multiple terms. We do something in algebra called adding the opposite. And we do that a lot with signed numbers, but we're going to do it here. And here's how we're going to remember it. We're going to draw the line to subtract and change the signs. So does that make sense now? We've turned this into adding the opposite. So we just took the opposite of both of these things.
So what's the line?
Draw the line and change the signs. Draw the line, and I'm going to say it a whole bunch of times, so it'll get stuck in your mind like a bad, whatever, a bad song. It would be a really bad song if you made a song out of that. Okay, so notice what happens now. What happens with x cubed minus x cubed? That's what our goal is, right? So they cancel out, and then we have 4x squared plus 2x squared. 6x squared. And then at this point, what did we do with the numbers?
You drop them.
Drop the next one down, and we're going to do the exact same thing. Minus 5x. We bring down the 5x. So we've just done step 1. We canceled out the first term, right?
So we don't bring down the 14 yet.
We could. I usually don't, but you could. That's fine. Question.
Never mind.
Was that the question about the 14? Okay. Something else? Okay. So we canceled out the x cubed. Now our goal is we move on to the next one, and we want to cancel this out. 6x squared. So remember, here's how we're going to do it. We're going to take that 6x squared and divide by what we already have right here, which is x. And what do we get when we take 6x squared divided by x?
6x.
6x.
Wait, how did you get there?
Okay, we took this, the 6x squared, because whatever we're trying to cancel, that's what we use, and we divide by what we already have, what we're dividing by out here. So the 6x squared divided by x. So again, if you think about all the pieces, that's 6 times x divided by x. So one of the x's cancels. So the 6 doesn't get affected by the x on the bottom. Just stays there. Okay, so that tells us we're going to multiply by 6x. And we're multiplying that by this x minus 2. And when we multiply that, what do we get? Here we're going to get,
6.
that's good because that's what we need, right? And then here we're going to get what?
12x.
Minus 12x. So we're going to take that and put it under here again. So 6x squared and minus 12x. Okay, is everybody with us so far? And now what do we want to do after we put that under there? We want to subtract. So we're going to draw the line and change the signs. So draw the line, change the signs. Okay? So what happens with the 6x squareds? They cancel out. And that's good because, again, that's what we want to have happen. What happens with the negative 5x and the 12x? It's going to be plus 7x or just 7x. And then bring down the minus 14. Okay? And we've done step 2 now. Now our goal, we want to get rid of this one. This one might be a little bit more obvious. We might just be able to look at it and figure it out. But let's go ahead and divide anyway. We've got the 7x that we're trying to cancel out. And we're going to divide it by what we have over here, the x. So what would we get there? 7. Oh, hang on. I forgot to put my 6x up here. I don't want to forget that. That's my answer. That's the important part. Okay. Are we okay with the 7? Okay. So we're going to take 7 times x minus 2. And that gives us 7x and minus 14. Okay. So we're going to put that under here. 7x minus 14. And then what do we want to do once we put it under there? Draw the line, change the signs because we're subtracting. And what happens with our 7x? It cancels out. And in this case, what happens with the 14s? They also cancel out. So our remainder is 0. That means it divided into the x minus 2 divided into this evenly. Right? Okay. So let's see. What do I have to put up here? Plus 7. And this is our answer. But each time you're just trying to cancel out one term at a time. Okay? Yeah.
So, let's say, for example, that last step, if we're going to equal to 0, will we have just put remainder?
Yes. Okay. So the question is, if this 14 and this 14 would not have canceled out and we had like a 3 there or whatever, something other than 0. What you would do then is you've got those two options. We could put remainder 3 at the end, or we could put plus 3 over the x minus 2. And depending on what we're doing when we're asked to do this division, we'll give one or the other of those answers. So on the homework, it'll probably just say write it as a fractional remainder, or write the remainder as a fraction, which means you'd put, like I said, if it was a 3 over x minus 2, or it may just say write it as a remainder, and you just put r, whatever. Or it may just have a separate box for the remainder. Okay. Now, another question that's kind of from that is, how do you know when you're done? How do you know when you're going to stop? And how do you know you've gotten to the remainder? Well, here's the rule. Once, now this one was obvious because it came out to be 0, but once your degree of this, and we just talked about degrees on that test we just took, so hopefully we kind of have that in our minds. But once the degree of this is less than the degree of this, you have to stop because you can't make it cancel anymore. So what is the degree of this? Not 0. It's the exponent is a 1, right? If there's an x there. Now what's, again, if there was a number here, what's the degree of that number? 0. Okay, if it's just a number, that's degree 0. If it's just a variable with no exponent, that's a degree of 1. So this degree is less than this one, so we know we're going to stop. That's how we can tell. Okay? Some of you are like, got that wrong on the first problem of the test. Yes, ma'am.
So what happened to the -2?
What happened to the
Where do you leave it?
this?
Yeah.
It's just what we divided by. Or are we talking about this part?
Yeah.
Okay, and what your question is, where did it go, or what?
Where did it go?
Okay, so think back to what we're doing. We're dividing, right? So if I ask you to take 12 and divide by 3, what do you tell me? The answer is 4. So that's what we're doing. We're taking this divided by this, and the answer is this. Just like the 3 doesn't go anywhere else, it's just this is what we divided by. This 4 is our answer. Same thing. This x minus 2, we don't have to do anything else with it. It's just this is our answer. Does that make sense or no? It looks like no. From
So
the
you
look
don't
on your
do-
face, it looks like
You
no.
don't do nothing with the -2 other than just multiply by.
Yeah, because that's what
whatever
we're
the x.
that's what we're dividing by. Just like in our example, the 32, we divided by the 32, and the only reason we possibly used it at the end was to make that fraction with the remainder.
So when you have an x on the outside, you just work with the x.
You're just dividing, and then you're going to be done. So that didn't answer. Like I said, I could tell from the look on your face.
I'll figure it
Just
out.
keep going. You'll figure it out. Okay, she's going to figure it out, and we'll keep going. Now, so this is the problem we just did, and we found out that it divided in there with no remainder. Now that leads us to something else, I think. Okay, so there's our quotient. They call it the quotient as the answer, and then the remainder. Sometimes they'll have a separate box for that. Remainder was 0. Quotient. It means the answer when you divide. Okay. Now, looking at this, the question says find the x-intercepts of, and you'll notice that this function they give us is exactly the same as what we just were dividing, right? Does that make sense? Everybody see that?
Yes.
Okay, so here's what I want to show you. When we divide this, and I'm going to erase a lot of this. Everybody got written down what they want to have written down? Okay, I'm not going to erase all of it, but I need to erase some of it. Okay, so this is what I want to have left, and I want to show you something here. So I use that example of 12 divided by 3 equals 4, right? And that's true. Everybody's okay with that? Now, what that means is if I take this 4 and multiply it back by the 3, our answer is 12. Does that also make sense? So I'm going to do the same thing here. If I take this x squared plus 6x plus 7 and multiply by what we divided by, the x minus 2, that answer is equal to x cubed plus 4x squared minus 5x minus 14. Okay, when you divide and it divides in there evenly, you have found what we call a factor because it divides in evenly. And when it divides in evenly, we know that this thing, what we were dividing by, and this thing, our quotient, if we multiply them together, we would get back to what we started with. Just like we did with 12 divided by 3 equals 4. So that means 4 times 3 equals 12. Now, obviously, this is a lot shorter, but it's the same rule. Okay?
Called checking, isn't it?
Yeah, if you would multiply this back out and actually do the work, you'd be checking your answer. Yep. Now, what we're going to do in this question is we're trying to find the x-intercepts. Okay? Do you remember how, and this was on your test too, so I'm hoping you kind of remember, but do you remember how we find x-intercepts?
Put it here.
You put a 0 where?
So why?
Yeah, you put a 0 in place of this f of x. Okay, so I'm going to erase this top part now. And so what we're going to do is we're going to replace this with a 0. And we have x cubed plus 4x squared minus 5x minus 14 equals 0. And do you remember what we would do then after we did that on the problems that you were working on? Wouldn't we a lot of times try and factor it?
You would have parentheses.
Right? Parentheses. And do you notice we've already got that done because we know that this is equal to this. Because I had you do that beforehand just so that we would know that it divided in evenly. So does that make sense that we can jump to this point? 0 equals, actually, I don't want to use all that board space. So let me put it up here. So this means 0 equals this, x squared plus 6x plus 7 times x minus 2. Now we didn't do the factoring like we would normally factor, but because of our previous example, does it make sense that that has to be true? Okay, and we'll do some other examples. You'll have some like this, but this is going to be a major topic that we do in the rest of this chapter. Is we're going to divide by something, and if it divides in evenly, then we know that those two things multiply together to equal what we started with. Okay, so now I'm going to erase this because now I need the board space. So we've already broken it into two factors, right? What we want to do then is, this one's going to be easy to solve. We want to break this one down again. And this one looks like something that we might be able to factor, right? Because it's a quadratic. We learned how to factor quadratics.
But if the sign is no, we can't.
What?
We can't.
Well, let's see if we can.
Okay. We can't.
Did I copy that down correctly? Was it x plus 6 plus 7? It was, right? Okay, so if we check it, we'd have 1 times 7, which is 7. And what do we know about the signs of the numbers we're looking for? They'd be both positive or both negative. And in this case, they would both have to be positive. Okay? So factors of 7 that are both positive, 7's prime. So the only options are 1 and 7. Does that work? No, unfortunately not. So if we can't factor, what's our other option? The quadratic formula. Okay? Yeah, this is prime, but we can use, it's prime as far as integers, but we can use the quadratic formula to still find the other X intercepts. Okay? So we can't factor it, and we just checked that. So what we're going to do is we're going to say, okay, what we always do is we take this one and set it equal to 0. And we take this one and set it equal to 0. Now let's go ahead and do the easy one first because we've already got that. That's what do we get for this answer? You add 2, right? So x equals 2. And that means our x-intercept would be 2, 0. So that's one of our answers, 2, 0, from this one right here. Now we've got to go deal with this one, and we already said we can't factor it. So let's identify the A, B, and C values for our quadratic formula. What is the A value for this?
1.
1. If there's no number written, it's automatically a 1. What's the B value? 6. And the C value? 7. Correct. Okay. Now the quadratic formula was on your test. I don't know if you needed it or not. I don't think you did. Maybe you did. Can't remember. But I'm going to write it down up here. You may want to put it in your notes because we will be using it from time to time. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And what we're going to do is we're just going to plug in the numbers. So what do we put in place of the b?
6.
Just a 6. I mean, the negative's already there, but then we've got a 6, right? And then we put in our plus or minus and our square root sign. And then we've got another b, and it's getting squared. And what do we put in place of the b? 6. And then we've got a minus and a 4. And then we've got an a and a c. What do we put in place of the a? The 1. And what do we put in place of the c? 7. All right. And we've got a 2 and then an a on the bottom. And again, what do we put in place of the 1? Or place of the a is a 1. Okay. And then we just start simplifying. Obviously, a negative in front of a 6 makes negative 6, plus or minus the square root sign. And honestly, for you guys, if you want to put that all in your calculator at once, you can and get the answer right away. But I'm going to go ahead and do it in 2 steps. 6 squared is 36. And we've got our minus sign. And 4 times 1 times 7. What's that going to be? 28, I heard somebody say, and that is correct. And then on the bottom, 2 times 1 is 2. Okay. So negative 6 plus or minus. So we keep working inside of our radical. What is 36 minus 28?
2.
8. 8. And then we still have the 2 on the bottom. Okay. Now, it's not 12. Sorry. I know how you got 12, but it's not 12. All right. So now we want to simplify this 8. Do you remember how we break up the 8? We do like prime factors. And how can we break up the 8? 4 and 2? Because you're multiplying. And then 2 and 2. So we've got 3 2s, correct? How many do we need so that we can pull out a 2?
2.
We need a group of 2, right? Do you remember that? So you're going to be able to bring out a 2, and you'll have a 2 left inside. Lots of 2s running around here. Okay?
2 squared. 2.
So here's what we do. When we have a situation like this, we're going to have negative 6 plus or minus. We're going to bring out the 2, and we still have a 2 left inside. Is everybody okay with that? This group of 2s is why we can get a 2 out of the radical. And then this 2 is still stuck on the inside. And then it's still divided by 2. Am I getting too low so people's heads are getting in the way?
You're not gonna do another one, so I appreciate it because I'm over here trying to catch up at the same time.
Too much laughing.
Too
Too much laughing.
Not just that.
Not just that.
Not just that.
Okay. Now, here's how we're going to finish this. Does this 2 look like it might be able to cancel with some of the stuff on the top?
No.
Like 6 and 2 and everything? So here's what we're going to do. I'm going to pull it up a little bit so we can see better. But what we're going to do is we're going to split this fraction into 2 fractions. And the 2 goes underneath both parts of our fraction. So this is going to be x equals negative 6 over 2 from the first part, and then plus or minus, and then 2 square root of 2 over 2 from the second part. Okay, and we just break that up. So do you remember how when we added fractions and subtracted fractions, we had to have a common denominator before we could combine them? Well, here they're already combined, and we're splitting them into 2 separate fractions that have a common denominator. We're kind of working backwards, but it's easier to cancel them this way because what is negative 6 divided by 2? Negative 3. And then what happens, and then plus or minus, and then what happens with this one? These 2's on the outside can cancel out. Okay, so we get that. Now here's where we're almost done because we just have to write it as an intercept. But we want to make sure we understand this is actually 2 separate answers because of the plus or minus sign. Okay, so this means one of our answers will be negative 3 plus the square root of 2, comma 0. And then the other one will be negative 3 minus the square root of 2, comma 0. So there was our first answer. Here's our second answer. And here's our third answer. And those 3 are all intercepts, X intercepts of that function. And right now you're saying, that took forever to do. And it took a little while to do. And that's why your assignment will be a little bit shorter this week than on these types of lessons, because I know it takes a little bit longer to do. So I give you less problems to do.
Can I take a picture of this?
Sure.
Thank you.
Should I get in the picture and pose?
I mean, can I get extra credit?
I don't need to be. I wasn't going to go in the picture anyway.
Nah, it's not good. I'm just messing with you.
I'm not. I wasn't going to go in the picture.
Is there like a smart calculator for this?
There are calculators.
$500.
There are calculators on the. There are like programs on the computer that will divide it for you, but
I need it like for the.
that's not going to be.
So
helpful. You can't use that for the test anyway. So.
Yeah. So, can I ask a question?
Yeah.
I think I got lost since the
Okay.
beginning. Well, just on the one, how do you
Okay.
have this six?
Okay. Sorry.
How do you end up with that for this X?
This part.
No, no, the top, the beginning.
Here.
Yes.
Okay. So this came from the problem we just did in the previous example.
Mhm.
So when we divided
Yes,
that.
That was their answer.
Yep. That was our
Yes.
answer.
Mhm.
So that meant you got this big thing divided by this equals this. So what that means is this answer times that equals this. Okay, so that's what we did is we took this and we replaced it with these two multiplied by each other.
Okay.
So this was our answer from our previous example, and this is what we divided by in our previous example. So we know that they multiply together to be this one.
Okay.
Okay, and that is always how it works. If you divide something, again, it's just like my example was if we take 12 divided by 3 and the answer is 4, well, that means that 4 times the 3 that we divided by is going to be 12. It's just like the reverse. One is a multiplication fact, one is a division fact, but they have to go together because of how they
So
work.
the 7 you got it because 7 times 7 is negative 14, right?
Well, I mean, these are both from the previous example.
So that's for-
Yeah.
okay.
But yes, you're right. If you were multiplying, the 7 times the negative 2 would give you the negative 14. So if we multiplied this back out, which we're not going to do,
Oh, okay. So
we would
you
get back
have
to
the
here.
answer. Okay.
Yeah. Okay.
Okay.
Any other questions on that example? Yes, ma'am.
Okay. What if the negative b was already a negative?
Okay. So right here, you're talking about.
Yeah.
So what if this 6 was already a negative 6?
Yeah.
Then you're taking, and that's why I usually will say the opposite of b. So if b is negative, you just change it to a positive. The two negatives cancel out.
See, that was on our test.
You learned that the hard way? Okay. Yeah, that, oh, you mean like when you put in like x minus a negative number or something?
No. Just like right there, like I didn't know if you.
Yeah, it turns into a positive. Because it's really, it's the opposite of whatever number is there. So the opposite of 6 is negative 6. The opposite of negative 9 would be positive 9.
So think of negative b as the opposite.
Yeah, opposite of b. Okay?
Thank you, sir.
Very good question. All right. So there are our answers listed just all together. Those are our 3 answers, 3 X intercepts. And let's try to do another one here. Now notice this one is strictly just a division problem. So what goes inside of the division sign here?
2x third and 7x.
Yeah, that. Now, here's one thing we have to be a little bit careful of, and it didn't happen on the last example. But notice we have 2x cubed.
We don't have
We do not have an x squared term, right? And we want to have an x squared term. So this is what we do. We put in what's called a filler term. And we actually do this all the time with numbers. Like, for instance, this number right here. What is this number? 17. How do you know it's not like 1007?
No comments.
Because there are no zeros in there to move the 1 over to the right place value, right? So it's the same thing here. We're going to put in 0x squared so that everything lines up in the correct place value. Yeah. Just so that everything lines up properly. And then we move on to the minus 7x. Yeah. I mean, it's invisible up here, but we're going to write it down because later on in the next thing that we do, we're going to have to put the 0 there. Otherwise, everything will get messed up.
So it's kind of like whenever there's an X by itself, there's. an
Automatically a 1 there. Yes. And then plus 3. And then the x plus 3 goes on the outside. Okay? So, like I said, the zeros here don't change anything except for they move the 1 over into the correct spot, right? Just the same thing here. This 0 x squared doesn't change anything. It just keeps the x cubed in the correct spot. All right? And like I said, that's going to be more important in our next topic. So what do we do first?
2x cubed divided by x.
Yeah, we want to cancel this out. So we take this 2x cubed and we're going to divide by the x. So 2x cubed divided by x. And again, as you start doing this, you can probably do that in your head. What do we get here? 2x squared. So I'm going to go ahead and put that in here. I'm going to line it up with my 0x squared because we know that's right because we did that. So 2x squared. And we have to multiply it by x plus 3, the number we're dividing by. So what do we get for this first one? We distribute that. 2x squared times x. 2x cubed. And then 2x squared times 3. 6x squared. So we're going to put that here. 2x cubed plus 6x squared. So we wrote it down underneath there. What do we have to do next? We need to subtract. So we're going to draw the line and change the signs. Notice it doesn't cancel until you make it a negative, right? Otherwise, it would just be a 4x squared. But we subtract, and so it's going to cancel. Does that make sense? Remember that? And the 2x cubes cancel out. What is 0x squared minus 6x squared? Negative 6x squared. And then we bring down, if you want to bring them both down, that's fine. I usually only bring down one at a time, but you can bring them both down. Okay? Now, this hasn't happened yet. I don't think we've had a negative here yet. But notice we do the same thing. We're going to take this negative 6x squared and divide by the x from right here. And that's going to be what? Negative 6x. And we can put that right here. And negative 6x times the x plus 3 will give us what for the first term?
Negative 6x squared.
Correct, negative 6x squared. And what for the second term? Negative 18x.
So you want to do the x plus 3 for all the.
Yep, every time we figure out what number to use, we always multiply by the x plus 3. Because that's what we're dividing by, so that's what we have to use to multiply to see what we're going to cancel. Just like in our number example, we always use 32. We use the 32 because that was what we were dividing by. So we put this under here, minus 6x squared and minus 18x. And what do we need to do now? Draw the line, change the signs because we are subtracting. So that becomes a plus and that becomes a plus. And once we change the signs, what happens with our 6x squareds? They will cancel. What do we get for the x's?
11.
Positive 11x. And then we bring down the 3. Okay? Then how are we going to cancel out that 11x? What are we going to have to multiply by? 11. So I'm going to put my 11 up here. And 11 times x plus 3 gives us 11x and
33.
plus 33. So I'm going to put that under here. And then what do we have to do? Subtract. So we're going to draw the line and change the signs. And what happens with the 11x's? They cancel. And what are we going to get here? 3 minus 33. Negative 30. And now we're going to stop. And the reason we're going to stop is, what is the degree of this negative 30? 0. And what is the degree of this one?
1.
1. And when the degree of this is less than the degree of this, then you stop. So we would have remainder, negative 30, or like I said, the other way to write it is 2x squared minus 6x plus 11. And then you could put the minus in the front, but you would put 30 over x plus 3. Well, like I said, sometimes they'll want you to write the remainder separately. Sometimes they want to do it that
How
way.
is the computer gonna like it?
It's going to ask for different ones, different ways, different times. But it's important that you learn how to do it both ways, because sometimes when we do this, we want to see it written as a fraction because of what we're going to do with it. And then the other times we want it to be written as a remainder because of what we're going to do with it. So it just depends on the situation. Yeah.
Just to make sure, if it wasn't, instead of negative 30, if it was just regular 30, positive 30,
Yep.
it would be plus
It'd be plus 30 over.
30 over.
Yep. In fact, sometimes people will just put a plus and then put the negative 30 up here. But there's not really any reason. You can put the negative in front of it, and then you don't have to worry about it. It's the same thing. Adding a negative or subtracting, it's the same thing. Okay?
It's clicking.
It's clicking?
It's clicking.
Yeah, you confuse me, because like in class you're like answering all these questions, and then you get to the test and you're like, I just did horrible on the test. I don't know what's going on.
I'm horrible at this thing, but when it comes to class,
You know that's a
when
disease,
you
right?
explain it,
I know there's a test anxiety thing.
when you
but-
explain it during class,
It's
like
like,
clicking,
oh,
it's in here.
And then you're going
As soon as that test comes, power it off.
Power off.
For real.
All right. So Oh. yes.
It's okay.
Okay.
I have a question.
Yeah.
Can I show you something? Are you gonna make it if we can do like that, is it possible or not?
What?
The first one you did this one,
Okay.
right?
Yes.
Can you do like that?
Well, we haven't actually solved anything else except for that first one. We've just been dividing.
Okay.
So right now you can't do that, except for that particular question. We made it an equation. Notice there's no equations here. It's just do this divided by this. But eventually, yes, we will bring that back. All right. So now we're going to learn a shortcut method. Now, it's a shortcut, and it is easier, but here's the deal. It doesn't always work. And I have to be careful how I say that. I'll say it this way. You can't always use it. Okay? Just like the shortcut when we were factoring, you could only use it when there was no number in front of the x squared. Well, the shortcut here can only be used if we're dividing by something that starts with just an x. If it's a 2x, we can't use it. If it's a 5x at the beginning, you can't use it. If it's a negative x at the beginning, you can't use it. If it's an x squared at the beginning, you can't use it. So you have to be dividing by just an x plus a number or an x minus a number to be able to use what is called synthetic division. Okay? And we're going to use this a lot, so you're going to get good at it. But we can only use it when this is just an x.
Just an X.
Just an x,
And
plus
plus
something or minus something. Okay? So here's how we do synthetic division. The first thing we're going to do is we're just going to put this little like corner up here. It looks like a backwards capital L kind of, but it's just a corner. And what we do if we're dividing by x plus 3 is we always take the opposite of this number right here. So we're going to put a negative 3 right here in the corner. So that's the first thing. Figure out what goes in the corner. Then we're going to write down just the coefficients. Remember, the coefficients are the numbers from this. We don't have to put the x's in, just the numbers. So it's going to be a 1. And here's where I have to be careful, because this is 1x to the 4th. The next one has to be x cubed. But notice there is no x cubed. So what do you think we have to put in? A 0 for the x cubed. Does that make sense? You've got to have, if you start with x to the 4th, you have to have x cubed. And then you have to have x squared. And then you have to have x. And then you have to have a constant. You have to go in order. For the x squared, what are we going to have next? Negative 10. For the x, what will we have next? Negative 2. And then for the constant at the end, 4. Okay, so we've got our numbers written down. Then you're going to just leave a little space because we're going to put some numbers underneath these, but we're going to put a line. And you always do this the same way, so you're just going to get in this habit, and we're going to always do it the same way. So we've got the corner, we've got the coefficients, we've got the line.
Can you go back again? And
Yep.
do the coefficient?
The coefficients,
Yeah.
this is a 1, x to the 4th. For x cubed, we don't have 1, so we have to put in the 0. And then for the x squared, it's the -10. For the x, it's the -2. And for the constant, it's the 4.
Gotcha.
Does that make sense? Okay. So everybody got it set up? We're okay? We're going to do this several more times. You'll get it. But
Why do you did the -3s?
why?
Mm-hmm.
It's just always the opposite of this.
Okay.
Always. Okay? So here's what we do first. It's a really hard step. You take this number and you bring it down. Whew, made it through that first step. Okay? All right, next one.
What are you doing?
Then what we're going to do is we're going to take this number, whatever's on the bottom here, and multiply it by the corner. And 1 times -3 is -3. That goes underneath our next row here. Okay? Everybody?
Is that an arrow underneath one?
Yeah, we just drop the 1 down.
So 0 minus 3.
So then we're adding. I mean, yeah, it becomes, so 0 plus -3 is -3. We always add. Just might be adding negatives. So then we take this -3 on the bottom and multiply by the corner. So -3 times -3 is +9. That goes underneath the next number.
That's nice.
And then we're going to add them. -10 plus 9. And that is -1. What do you think we're going to do with this -1 on the bottom? Multiply by the corner. So -1 times -3 is +3. That goes underneath the next number. -2 plus 3 is
1.
1. What do you think we're going to do with the 1? Multiply by the -3. And what is that? And where's that going to go? -3 right here. And then we add and we get 1. Okay, now obviously our answer is not 1, -3, -1, 1, 1. Okay? That wouldn't make any sense. But here's how we do this. What was the degree when we started up here? 4. When we divide using synthetic division, the answer is always 1 power less than what you started with. So this one right here means 1x cubed. It's now a 3. And then we just go down from there. So the next one is -3x squared. And the next one will be -1x to the first, but we just write x. And then +1. And then what do you think this last one over here might be? The remainder. This is the remainder. Remainder 1. Or again, you could write it as x cubed -3x squared minus x plus 1 plus 1 over what we divided by, which was the x plus 3.
So our degree was 5, it would start at 4, then
Yep.
3, 2.
If this was, yep,
etc.
Yep. It's always less. Whatever this is, it's always 1 less.
So whatever the last whole number is, the numbers that come after that don't have a degree is going to be a remainder. Does that make sense?
Once you run out of x's and a constant, the last number is always the remainder.
But there can't be more after that, right?
No.
Okay.
That's you just when you get to the last one, you just stop. So because you've run out of numbers, so you just stop.
How do you get the first step, just number 1? Just
This one?
copy it down?
You just drop it down. Just whatever's there, you put it down there. Okay. Now there is a reason that this always works the way that it does, based on long division. I'm not going to show you that, but if you go back and look at it and you actually do the long division with the same problem, you'll see this pattern of these numbers coming through. But we're not going to do that right now. So, okay. But we get our answer there, and that's the answer. Okay. That one makes sense. It's a shortcut, but again, it only works if this is just an x. All right, so let's do another one.
So if it's like just only x long, it work or not?
If it's just an x, then it will work. So
Should
notice,
work on that one.
notice on this one, we can use synthetic division because it's just an X. What's going to go in the corner?
+3.
Positive 3, because it's always the opposite of what you see here. Right? So if we see a negative 3 here, it is a positive 3 that goes here. Okay? Then we want to write down our coefficients. What's going to go first?
Fine.
The 5. What's going to go after that? Negative 2 for the x squared. What's going to go after that?
0x.
Perfect. 0, because there is no x term, right? And then what's going to go last? The 1.
Oh.
Make sure you don't miss that 0, because if you miss the zeros, you're going to mess up your answer. So you got to make sure you check. Okay? X cubed, x squared. There's no x term. I got to put in a 0 and then constant. And then we're going to put our line underneath here. So what are we going to do first now?
Bring down the 5.
Bring down the 5. And what are we going to do with that?
Times it by 3.
5 times 3 is 15. And then?
And 15 plus negative 2.
Correct. And that is 13. And then?
13 times 3.
13 times 3, which is 39. And we add 39 plus 0. That's an easy one. 39. And then we take 39 times 3.
117.
What is it?
117.
117. And we add those and we get 118. So now what is our answer? 5 what?
X squared.
X squared. Perfect. Plus 13.
X.
X plus 39. Just 39. And then remainder 118. Or we could put plus 118 over x minus 3. Okay. Isn't that quicker than long division?
Love this.
But again, it only works if that's just an x that you're dividing by. If there's ever a number by it or something else, you can't use this method. No, you just do long division. All right? Make sense? Good. And again, either way that we write that, just look at what the computer is asking you for on the homework, and then you'll know which way to write it. If there's 2 separate boxes, it wants the normal answer and then the remainder separate. And it'll have them labeled. It'll say quotient for the top one and remainder for the bottom. Okay.
Let's test
Let's test on this.
right now.
I don't have a test right here for this right now. Plus, we have to do 4 more lessons after this. So, okay. Now, the rest of what we're doing is using synthetic division. So we have what is called the remainder theorem. And theorem is just a fancy word that means something that's been proven. We're not going to take the time to prove it, but it's something that has been proven in the past. So if the polynomial p of x is divided by x minus c, so we're dividing by this, which means we're going to be able to use synthetic division, right? So it's divided by x minus c, then the remainder is equal to the value of p of c. So here's what that means. If we took something like this last problem and we divided by x minus 3, then that would mean p of 3 would be, what was the remainder on our last problem? 118. So in other words, if we took that polynomial and plugged in a 3 for all the x's and did the math on our calculator or whatever, the answer would be 118.
Wait.
Okay?
So we're going to plug in the negative 1.
I'm just using that as the example because we just did that one. Because this is the numbers we just did. We are going to do, oh, you're talking about the example there? You've got the example right here. So what we're going to do is in the corner. Now notice this is different. Do I have an x plus or x minus something that I'm dividing by? No, they're just giving me a specific x value. When they just give you a specific x value, you just put that in the corner. That's the thing that people get mixed up. If you're given the factor x plus or x minus, you have to change the sign. If they just tell you, use this x value, you just plug it in. Okay? And then what are we going to write down here for our coefficients?
5.
Nope, there's one before that. Or actually, there's 2 before that.
Oh,
Yeah.
The x minus
1 for the x to the 4th, and then 0 for x cubed, negative 5 for x squared,
4.
4 for the x, and 12 for the constant. And then we put our line.
So now we didn't change the negative to a positive?
No, and that's what we say. This is not like, they didn't say divide by x plus 3 or divide by x minus 2 or whatever. They just said, use this x value, negative 4. So that's the difference between the two. Okay, so what do we do first?
You bring down the one.
Bring down the 1. Then
Negative.
multiply, and we get negative 4. And then add, and we get negative 4. And then multiply, and we get 16. We do get 11. Multiply, negative 44. Negative 40 is correct.
Oh my gosh, thank you.
And it's going to be positive, right? Positive what? What's 4 times 4? 16. So 4 times 40? 160. And we add 172. Now, where's the remainder?
I don't have one.
There's 0.
No, where's the remainder?
172.
172. So here's what that means. P of negative 4 is equal to 172.
That's it.
That's what this question was asking, and that's our answer.
That is awesome.
Okay? It's just this remainder. So again, when they say evaluate P of negative 4, you put in the negative 4, you do the work, and your answer is the remainder. Okay? Now, I will tell you, with a calculator, it's probably just as easy to type in negative 4 to the 4th minus 5, negative 4 squared plus 4 times negative 4 plus 12 and get that same answer. But what we're doing is we're setting ourselves up for the next couple of things that we're going to be doing in the next lessons. Okay? So that's that.
If we do to that other one,
What other one?
that's the problem.
The next example? Yeah.
On our
This
own.
one? Oh, you want to do it on your own? Okay, go for it. Is it the last one? No, it's not the last one. There's something less left.
Last one before the factor theorem.
I don't have the notes in front of me, so I have to look.
The last example. Right.
Okay.
Okay, I'm not You know, I'm more confused on what to put in the first row, you know, after the negative
Your
1.
coefficients.
Yeah.
Like,
So what are we going to put there, Antonio?
yes.
What are we going to put there?
I don't know.
2 for x to the 4th,
Okay,
what is-
6.
and then 6 for x cubed,
Oh, okay, I get it.
then negative 5, and then be careful. What's next?
0.
0 for the x, because there's no x, right? And then last one is negative 59. Okay. Then you'll draw your line. And I'll do it up here quietly, and you guys can do it and check your answer when you're done. Were we able to get this?
No.
Okay.
And we make put that.
Well, look back. Where'd you get wrong?
I got the 2 and the 4.
Okay. 4 times negative 1 is negative 4.
And then 5 minus 4.
It's negative 5.
Oh,
Did you copy it wrong?
yeah.
Okay. Yeah, make sure you're careful with your signs. They will mess you up. Any other questions on that one?
I feel like it's clicking now, but when it comes to the test again, it's gonna be the same.
Well, you're going to do a lot of practice, and then you're going to make sure it still clicks.
Over your brain, okay.
All right, the factor theorem. Now, this theorem is a direct result of the previous theorem we just talked about, the remainder theorem. Here's what the factor theorem says. A polynomial f of x has a factor x minus c if and only if f of c equals 0. Or actually, it's related to the previous one, I should say. And hopefully this makes sense, right? Because what does it mean for something to be a factor of something else? Like, is 7 a factor of 12? No, because why?
Or there's nothing that times it.
Yes, there's nothing 7 times. It doesn't divide in evenly. That's the idea, right? It doesn't divide into 12 evenly. Is 6 a factor of 12? Yes, because 6 divides into 12 evenly, which means no remainder, right? Or a remainder of 0. Now, what is this side saying? F of c equals 0. Well, if we think about our remainder theorem, what is this saying? This means the remainder is 0, right? So this is just really saying kind of something fairly obvious, but it's going to give us the ability to check these factors using our synthetic division. Okay? So here's what we're going to do. We're going to show that x minus 2 and x plus 3 are factors of this polynomial. So for the first one, what do we write in the corner? Positive 2, because you're seeing the factor x minus 2. So you have to switch the sign, right? They didn't just say x is. They said, here's the factor, x minus 2. Okay? And then we've got coefficients 2, 7, negative 4, negative 27, negative 18. No missing ones that time. And what do we do first? Bring down the 2. 2 times 2 is 4. 7 and 4 give us 11. 11 times 2 is 22. Negative 4 plus 22 is 18. 18 times 2 is 36. 36 and negative 27 will give us 9. 9 times 2, 18. 18 plus 8, negative 18 plus 18 is 0. Now, what we did is we just showed that this was a factor. We knew already it was going to work, or that it should work, but we now showed that it was true. Okay? So we've done this one. What do we have to do to show that that one's true?
-3.
We just do the same thing with a negative 3. And so our numbers are 2, 7, negative 4, negative 27, negative 18. If you guys want to try that on your own, you can, but I'll do the numbers up here. Hopefully when you do that, you get the 0 at the end. Yes, ma'am.
Why you didn't add a 0 on this one?
Okay, so the only reason we added zeros in the other ones is because there was a missing term in our what we were dividing into. So this one had x to the 4th, it had x cubed, it had x squared, it had an x, and it had a constant. So if we go back to like this one, notice it has x to the 4th, it has x cubed, it has x squared, but it doesn't have an x. So that's why we have to put in a 0 for the x. Does that make sense? So if you go all the way back to the very beginning, we put the 0x squared because it was missing a term. That's why we do it. If there's ever a missing term. If there's no missing term, like these, this one doesn't have a missing term, then you just write down the numbers. That makes sense? Okay.
So that's it.
And was everybody able to get it to come out to be 0? Okay. And so we just showed that those two things were factors of the original. Okay. Now I'm going to show you one other thing so that you can, because this is eventually where we're going. So just throw that aside for a second. If we take these numbers that are from our answer right here, actually, let's go back to this. Let's say 24. How would you break up 24? 12 and 2. Okay, so I've taken a 2 out of the 24, right? But I still have other factors left in the 12, right? Okay, 6 and 2. And then I can keep breaking it up until I finally get broken up completely. Well, what we figured out is x minus 2 divides into this. But we also want to show that x plus 3 divides into it. So we can take what we got for our answer, like this row, and we can keep breaking this part up. And we can use the -3. And notice what happens. 2 times -3 is -6, which gives us a 5. 5 times -3 is -15, which gives us a 3. 3 times -3 is -9, which gives us a 0. We can break this one up using this because we know that that goes into it. Okay, and this is actually eventually what we're going to do is we're going to keep dividing sequentially here one time after another to try and get it down as simple as possible and keep breaking it down like this, but with these polynomials. Yes, sir. Oh, sorry. Michael.
So my question is, our answer would be just showing the work that actually.
On this one, yes, just show the work.
Okay.
Yep.
And let's say one does and the other one doesn't.
Well, then you probably better double check. If there's now there won't be a question like that on your homework because you're not going to be able to show your work on the homework.
Yeah.
And there won't be one like that on the test either. But do you understand? It's just the process of this is how we would do it. Ariana, is that right?
Yeah.
Did you have a question too?
Well, we could do just the 2 steps.
Yeah, you could do them two separately. But like I said, eventually we're going to want to do this. So for right now, completely okay. But eventually our goal is to break this down like we do with prime factors. And not just say, oh, 2 is a factor and 3 is a factor, but to break it down until we get to the little factors. All right, I think we got one left, right? All right. Oh, and I've only got 3 minutes. I keep thinking it's 7:10. That's when the next class starts. Okay, the polynomial p of x equals this, has horizontal intercept at x equals 1/2. Notice they are giving us an answer, right? And it has a multiplicity of 2. Now, if they give you the number, you just put it in. So what's going to go in the corner is 1/2. I know we don't like fractions that much, but that's what goes there. Just they tell us to use x equals 1/2. So 4, -4.
What's the meaning of
What?
multiplicity 2?
That means it happens twice. Remember how we have a factor that happens twice? So we're going to do it twice. Yep. 12 and -3. Okay. So we just, and I'm going to have to do this fairly quickly to try and get down. I'm sorry. 4 times 1/2 is 2. -2. -2 times 1/2 is -1. That gives us -12. -12 times 1/2 is -6. That gives us 6. 6 times 1/2 is 3. And that works, which again, they kind of told us that it would work. But here's what else they tell us. That 0 has a multiplicity of 2. So it's going to work again. So we're just going to go from here and we're going to do it again.
Oh, for the homework, or if we were to get it as a homework problem per se, would we have to do that second step as well?
Yeah, because our goal is to find the other intercepts and we can't get to the other ones without getting rid of these first. It's like as we're breaking down our prime factors and we want to get to the bottom level, this is what we're doing. So the 4 comes down. 4 times 1/2 is 2. That cancels out to be a 0. 0 times 1/2 is 0. That'll be a -12. -12 times 1/2 is -6. And we get a 0. So here's where we have to pay attention. This was x to the 4th originally, correct? When we divided once, what was this row? X to the 3rd. But then we divided again. So what is this row? X to the 2nd. So this is actually 4x squared. There's no x. And this is a -12. And we still want to find out where it equals 0 because we're looking for the other intercepts. But this one's a really easy one to solve because all we have to do is get this x by itself. These are really far apart. Let me put them closer together. Does it make sense? What we're going to do next is add 12. So 4x squared equals 12. And then what would we do? Divide by 4. I'm going to bring that up here. So x squared equals 3. 12 divided by 4. And then what would you do to get rid of this? Square root of both sides. And when we take the square root of both sides of an equation, what do we have to put in front of that? Plus or minus. Okay, so if we were going to list all the intercepts, we'd have 1/2 comma 0 because they gave us that one. It actually occurs twice. And then we would have square root of 3 comma 0 from this top one. And what's the other one? Using the bottom, it'll be negative square root of 3 comma 0. Okay, so that's going to be our goal eventually, is we want to be able to find all these intercepts. And right now we're going to be given some intercepts to help us out, but eventually we're going to have to just figure them out by ourselves. And that's what we're going to be learning.
And they apply the same thing on that one. We don't change the.
You don't change it because they just said use this x value right here, so we just put it in. Okay, and that's the end.